All right. So today is pretty much a review day, which is great because it's nice to not have to lecture new material right before an exam. Our exam is going to be this upcoming Wednesday. I do plan on just giving you the entire class period. I don't think we really need to do a full review before it because today will be the review. So we'll just come in, probably maybe like give an extra 10 minutes for everyone to be here, get set up, and then we'll start the exam and you'll have the entire day to take the exam. The exam will be probably the same as last exam, 25 multiple choice questions, followed by a little short answer, short response area. I haven't made it yet. I will be hunkering down today and tomorrow to create the exam. So don't quite know what I'm going to do yet, but it will of course be units 2.1 through 2.4. That's going to be, but I will kind of do something similar to what Dr. Patterson did, where she added maybe like a handful or a couple questions from unit exam one, just to kind of see if you're still on top of your material. But the predominant subjects will be units 2.1 through 2.4. We do have homeworks out and quizzes out. So there are, I think, 5 homeworks that need to be completed before this upcoming Wednesday at noon, and 3 quizzes. Reminder, your 2 lowest quizzes are dropped, your 2 lowest homeworks are dropped, but please, don't drop them without trying, at least. I'd rather you drop a failing grade than drop a 0. Yeah, so I will warn you, a lot of those quizzes, they need to be hand graded by me. I'm pretty on top of the grading, so I usually like once a day will go through and grade. So the ones that have already taken those quizzes, they're already graded. But yeah, so that's coming up, and then we'll start unit 3 next week. Okay. One of those quizzes is going to be entirely utilizing polyatomic ions, and I understand that it's hard to memorize a lot of polyatomic ions. I did give you a worksheet or a pass out sheet. It's under resources, and it has all of the polyatomic ions. So obviously for the quiz, you have 2 chances. I'd love for you to attempt a quiz, attempt with no notes, because that'll show you how ready you are for the upcoming exam. But you still have access to this worksheet under our resources module that have all the polyatomics I will ask you about. So at least for the quiz on the second attempt, you'll have access to that. But I will warn you, the quiz is not always going to be very straightforward. They're not always going to be an ion. So I was telling Logan, sometimes you'll be asked a question, what is an oxide versus an oxygen? I'm throwing that out there to trick you. So oxide will be an ion, oxygen. So if it's an element with its name out like that, it's going to be, it's just going to be by itself, so O2. So don't get tricked by those questions on the quiz. So if I say phosphorus versus phosphide, one's an ion, one's not. Okay. Yeah, that's, I think the hard part is I'll throw other things in. Any questions on that? Okay. Let's do this for a little bit because as you're preparing for the exam, if you could like maybe do like five minutes a day with something like this might help you recall it a little bit more for the exam. I feel like when I'm looking at a worksheet, I'm not going to be as easy to remember or memorize. But as you're going through memorization, I think this is a little helpful tool. If you want to have access to this, this is under our Achieve Homework modules under Practice, and this is common ions. So like, let's say this says name this ion. Well, first I have my periodic table with me. I know it's not fluoride, so it can't be these 2. And then it has a 2+, and that tells me the charge. So it's going to be iron 2 or iron 3. The Roman numerals tell you the charge. So even if you got it wrong, it'll definitely like give you another chance at it. But this really helps you kind of use the elimination process, which I will always advocate for exams. Elimination before you guess, because if you can give yourself a better opportunity for a higher percentage, great. So SO3 2-, this is a sulfur with oxygen, so it's something with I8 us. So I'll tell you now, it's not going to be sulfide because sulfide is just S. If it's an element by itself with ide, it's just going to be element ion. So it can't be sulfide. So we have sulfite, sulfate, and sulfurous. I've never heard of sulfurous. Like I just never heard of it. It looks like they combine sulfur and phosphorus. So I don't think it's that, just based on everything I've seen. So the hard part is picking, is a sulfate or sulfite? What do y'all think? Yeah, so you just gave yourself a 50-50 chance of getting the right answer, and your reaction was like, okay, let's say sulfate. It's not sulfate, and that's okay. But I do like the fact that you had a 50-50 shot. And so sulfate is SO4 2 minus. Sulfite will be SO3. It's going to be very hard, like if you were to like look at this and say if bromate is BrO3, chlorate ClO3, things like that. So I can see the way your mind's going. You're trying to go with the trend, and I respect that it's complicated. But at least we gave ourselves that 50-50 shot. So that to me is a good miss because we almost had it. So this one's kind of going off that last slide. This is just sulfur with a 2 minus. So this is never going to be just sulfur. Yeah, so it's not sulfate because that's SO4 2 minus. Sulfite is SO3 2 minus. So it's going to be between these two, and I don't know what that is. So sulfide. So yeah, use those answers to kind of help you eliminate. O2 minus. Is it a metal? So it'll never be with a Roman numeral because that's only for metals, specifically transition metals. Oxygen, peroxide, oxide. So these are good answers. Peroxide is O2, I think 2 minus. Yeah, O2 2 minus. So there has to be 2 oxygens for this to be peroxide. So now we have oxygen and oxide. Is it an ion? Is it a charge? Ion means charge. Do you see a charge?
Yes.
Yes. So this is going to be oxide, not oxygen. If it was oxygen, it would be no charge. It would be O2. It's a Brinkelhoff. So those exist as the diatoms. So H2, O2, Cl2, Br2. So like those are the ones that exist with the 2. So if I said bromine, it'd be Br2. Chlorine, Cl2. Fluoride, Cl minus. So the ide tells you it's an element, but it's an ionic state. So it has a charge on it. So oxide, O2 minus. All right. First, what element is Na? Okay. And they give us the charge. So this one makes sense, right? I mean, it's a 1 plus charge, but why is this not right?
It's not.
Sodium is a metal, but it's not a transition metal. It has a charge that's always going to be known, so we don't put Roman numerals on assumed charges. So like column 1 will never have Roman numerals, column 2 will never have Roman numerals. So this one, yes, it looks correct, but we would never put a Roman numeral because it's an assumed +1 charge always. Sodide, have you ever heard of a sodide? No, usually the ide means a negative charge. This is a positive charge. And when we talked about ionic compounds with naming, we just leave the metals as is. So sometimes we'll add the Roman numerals if it's transition, but in this case, that leaves one option. Yeah, nitride, no. Okay. PB, do y'all know what PB is? It's lead. Double check, you will have access to this periodic table. So definitely double check. So by knowing it's lead, we already eliminated half the options. So which one do you think it is? Yeah, the 2 plus tells you it's lead too. All right. What do y'all think this one is? Okay. Which one does not make sense? So phosphorus, if it was just P by itself, because phosphorus is not a Brinkelhoff, it can't exist by itself, that would be phosphorus. What about phosphide? What does phosphide look like? Yes. So it would be P3 minus. It's by itself, but it's in its ionic form, and that's its charge. So we already eliminated these. So with these two, you get phosphate or phosphite. And at least you're kind of flipping the coin here if you don't have it memorized yet, and you have a better chance. Which one is your reaction or your instinct going towards?
Phosphate.
I agree, phosphate. This is PO3 3 minus. Yes.
Number 3 was
Sulfate?
yeah.
Yeah, but double check because I'll tell you now. ClO3, chlorate, BrO3, bromate. It's not, it's like, it's easy to kind of think, okay, I'll follow a trend, but I'm telling you now, there's no trend. And I don't want to confuse y'all further. Cl minus. What do y'all think? Yeah, I agree. Perchlor or something would be with an O in there, so it can't be this. Chlorate, that's ClO3, I believe. Let me double check. Yeah, ClO3. Chlorite is ClO2, so it has to be chloride. What element? I don't even have to think, because all of the answer options are not calcium. This is one that doesn't follow that trend. Yes, this is perchlorate. So chlorate is ClO3, chlorite, ClO2, hypochlorite is ClO minus, but this is just Cl. That kind of leaves you perchlorate. So like I said, it's like these are kind of complicated, but the more you see it and the more you test yourself, and like, it's okay if you don't have everything memorized, but what if I had chlorate memorized? Then I know this is definitely not chlorate and gives me a better shot. So this is going to be really fun to like just get yourself ready. So what do you think? Not phosphite. It's not phosphate because that's PO4 3 minus.
Phosphide.
Yeah, it's phosphide. So if it was just P, it'd be phosphorus, but this is phosphide. And I'll tell you now, the quiz, the polyatomic ion quiz is very similar to this, where I'm like, I had you do it in essay form where you explain things to me, but I'm going to give you these types of problems and say, okay, what is it? And it's not just going to be ions. It's not. It's going to be a variety of different things. And you have to be able to say, okay, well, this has a charge on it. So it's not bromine, because if it was just Br2, because it's a Brinkelhoff, then it would be bromine. But it's bromide because it, it's an element by itself that has that ide on it and has so I can kind of ignore bromate, which is BrO3 minus, or bromite, I think it's BrO2 minus. Yeah, it has to be bromide. Do y'all know what element? Yeah, so this is chromium. Well, look at the options for chromium. What one has to be it? Yeah, so the one with the 3, because chromium is a transition metal and it needs to have a Roman numeral. So this one I kind of struggle with, but they were nice enough to not give you hard answers. So for me, I struggle going between ammonia and ammonium. I do. But look at the answer options. They did not give you ammonia and ammonium, which means there's only one option. This is ammonium. The ion is ammonium. NH3 is ammonia. Ooh, let's see if we remember everything. If you don't know on top of your head, tell me which one it is not. It's not perchlorate because that's ClO4. What else is it not? It's not chlorite because it's not ClO2 minus. Which one is it not? It's not chlorate because it's not ClO3 minus, and that leaves you one option. So that's kind of how you want to answer these if you don't have it quite memorized yet. But yeah, these are I think the CLOs are probably the most tricky. So it goes perchlorate, ClO4, chlorate, ClO3, chlorite, ClO2, hypochlorite, ClO. So yes, but the more you see it, the more you can kind of use those. Okay, this doesn't make sense. This doesn't make sense. What do y'all think? Yeah, we just did it, but it's on your head.
It's chlorate.
Yeah, like 20 minutes ago, confusing, but now that y'all seen it, it's like I know exactly what it is. All right, what is it? Fluoride. It's not fluorine. It has an ion. All right, what is it? Fluorite. Yes. What is it? And no worries, if you don't know that on your head, at least eliminate what is it not. What is nitrous? I know that that is a thing, but I've never discussed that with y'all yet. So that, I mean, obviously if you're a car person, they use a lot of nitrous, but I have no clue what that is. So it's not nitrous, not nitride. What is it? Good. So nitrate is NO3. So nitrite, it has to be nitrate. I think that's the trend that I'm seeing across the board. but it's like hard because phosphate is PO4, sulfate is PO4. And then like you go to the threes and the two. So yeah, I think it goes 8, then it's under it. Yeah, that's something that looks like it's always. Yeah. But as you're getting more and more comfortable, I highly recommend doing this over and over and over again until you are ready. But at least maybe like do it for 10 minutes today, 10 minutes on Tuesday, and maybe 10 minutes before you come in. And that might help you, be on the tip of your tongue for the exam. Versus, this is also nice to have it with you, but you want to do this without your notes. You want to see how comfortable you are without your notes. Go back. Okay. Last class, we started doing exam, I think it was exam 2 we went through. We didn't finish exam 2, so today we're going to finish exam 2, and then we're going to start on exam 3. So just reviewing things. So we have other things that we did last class that are relevant, but we ended it on 25. We're going to start on 26. All of exam 3, I believe, could be asked. So I'll warn you now, part of exam 2 and all of exam 3 are going to be good to go for this one. I'll point it out if it's definitely not going to be option. Number 26, can y'all see that or y'all need me to zoom? Which of the following pairs of names and formulas are wrong? This is a review of what we did last exam and this exam. Huh? So remember using ionic compounds, metal plus nonmetals. We don't really do we don't do prefixes. So it's going to be whatever the metal is, and silver happens to be a metal that's always going to be +1. So it does not need a Roman numeral. So silver nitrate is correct. What else? Oh, D. So nitrogen monoxide is correct. That is a covalent compound, and that does require prefixes. What else? Does C look correct? Why? Okay, so does it need prefixes or no prefixes? Not non-metals need prefixes. Okay. Metals do not need prefixes. Is barium a metal? So having a dichloride next to barium, does that make sense? So it's B. So once again, if you have to be able to look at this problem and recognize, is it ionic or is it the molecular covalent compounds? Molecular covalent compounds require those prefixes. So C and D are molecular covalent compounds. They need those prefixes. A and B are ionic. They do not need prefixes. So going between these two, it's like you can't have a dichloride next to a barium because barium's a metal. So this is a good one because it's really going to challenge, are you comfortable with unit 1? All right, let's keep going. The correct name for MgF2. Is it a metal? Is magnesium a metal? So anything with prefixes, I'm going to eliminate. Exactly. you just made your life easier because bifluoride, I've never heard of that. But if you eliminate what makes no sense, it helps you easily pick out the correct answer. So magnesium's a metal, fluoride's a non-metal ionic, magnesium fluoride. 30 is going to be a good challenge. It's just going to say, okay, how comfortable are you with polyatomic ions? Which of the following list of ions contain only ions with 4 oxygen atoms in their formula? And I recommend, even if you don't have these memorized, what ones don't make sense. Like look at A. Do y'all know what carbonate looks like? Like calcium carbonate, things like that. Okay, carbonate is CO3 minus, 2 minus. So because I saw that carbonate, I know A cannot be the right answer. I don't even have to check and see if it's an azide. Azide also is like N3 or something like that. Okay. What is nitrate?
One minute, reread.
NO3. So I know it can't be B because NO3 has 3 oxygens. So just by kind of picking out those 2 that I am comfortable with, I eliminated half the answer options. Phosphate, nitride, acetate, chromate, sulfate, perchlorate. So does anyone know what acetate is or nitride? I don't know if, okay. If it was nitrogen, it would just be N2. But if I have an "ide" on the end, so for nitrogen, it would be N3 minus. So nitride, N3 minus. Are there any oxygens in nitride? No, so it can't be C. So don't panic when I do give you this type of question. Pick out the things that you are comfortable with. Because even if I'm not comfortable with everything, I can still make an educated guess. So let's do this. So thiosulfate. Is that thiosulfate? I don't think I have that one in here. No. Oh yeah, I do have thiosulfate. S2O3 2 minus. Azide, that is N3 minus. Carbonate, CO3 2 minus. So that would be A. B, nitrate, NO3 minus. Perbromate, that's BrO4 minus. And phosphate, PO4 3 minus. So yes, these would be correct, but that nitrate causes it not to be B. C, phosphate, PO4 3 minus. Nitride, N3 minus. Acetate, C2H3O2 minus. C, and then D, chromate, that is, it's C, yeah, CrO4, but is it minus or 2 minus? I think it's minus. 2 minus. Sulfate, SO4, 2 minus. Perchlorate is ClO4 minus. So in this case, it has to be D. But we were able to pick out the ones that don't make sense. All right. This is a short answer portion from exam 2. How many molecules are in 39.5 gram sample of CH4 used dimensional analysis? This one, we need to remember the mole triangle. If you download the exam, the mole triangle is not given. It's not. But we can still remember things from the mole triangle. First we need to create some equivalents, I guess. Using the mole triangle, if I'm looking at CH4, what are the representative particles for CH4? And what I mean by that, is it formula units? Is it ions? Is it molecules? Is it atoms? Why? Yes, this would be molecules. When I say representative particles, I mean the smallest version of whatever compound I throw at you. If I had said, like, instead of CH4, if I would have said, I don't know, chlorine or carbon, then yes, it would be atoms because that's the smallest it would be. But this is a molecule. CH4 is a molecule. So if it asks for molecules, that is the representative particle. Going off the mole triangle, if I have 1 mole, how many representative particles is there? Y'all remember the number? And I'm gonna do MC because instead of me putting representative particles, I can just leave it as molecules. Okay. In the question, it mentions grams. So the third one part of that mole triangle is molar mass. Okay. So for me to go from grams to molecules, I just need to have the molar mass of CH4 and molecules. If you want to be consistent and just do the whole mole triangle out there, 22.4 liters is that last. So if you have this down, all you have to do is pick out the two that matter for the pressure, and then you could set it up. The molar mass of CH4, so that would be 12.01 plus 4, like 16 point something. So 39.5 grams of CH4 times, what am I putting in the numerator? And in the denominator, I have to put the molecular weight. And so my units will cancel. And double check my math. Okay. I'm going to leave this little mole triangle I wrote up here, and I'm going to let y'all answer the next one. I'll give you a few minutes. All right. So remember that if I need to get into CH4, the represented particles are molecules, not atoms. So because it's asking for atoms, and that's not the represented particles, this is when I need to remember I need one additional step. So how many atoms of hydrogen are in 3-liter sample of CH4? So I do need to use the 22.4 liters and the represented particles. Those are the two numbers we need for this one. But I might need an additional equivalent because it's asking for hydrogen. If I have 1 molecule of CH4, how many atoms of hydrogen? So I'll start with my given, 3.00 liters of CH4. And I'm going to want my representative particles on top. divided by my 22.4 liters on the bottom. Since I want my units to cancel. And if I left it at this, it would not be atoms of hydrogen, it would just be molecules of CH4. So to figure out the atoms of hydrogen, I just need to add this extra little equivalent on there. So my units will cancel. Remember, this question is, you're probably going to see something very similar, but what I can easily change is I can change any compound. I can change it to an ionic compound. I can change it to a different covalent compound. I can ask these exact same questions a million different ways, but the process doesn't change. Identify what are you given, identify what are you trying to get, use the mole triangle, create those equivalents and identify which two matter to the problem. And then sometimes you have to do that extra step if what it's asking for is not the representative particle. And remember in exam 2, there were some multiple choice questions that said, what is the representative particle? So you also want to be able to, identify what it is. Let's move on to exam 3. So this one says, use this information to answer the next 8 questions. Think about what each question is asking you to do. Some are dimensional analysis and some are not. So some are probably more straightforward. So it says butane is the fuel used in devices like a Bic lighter. When butane is pressurized, it turns into a liquid when it allows a lot more butane to be loaded into a lighter than if we're using, okay. The lighters are designed to, whatever, none of this matters. It kind of just tells you what the reaction. So the only thing I really care about is the reaction itself. First, calculate the molar mass of butane. So I think the way this one's written is like you need to be able to figure out which one is butane. Which one is it? C4H10. So what is the molecular weight of butane? Go ahead and calculate that.
So in this question, is it asking molar mass of butane from the equation or just in general?
You'll never double it. You'll never take that 2 and apply it to molar mass. That 2 is a stoichiometric ratio, but it has nothing to do with molar mass. It's there to kind of trick you. Don't let it. Just the compound itself. Okay. What'd you get? A, yeah, I agree. So yeah, don't worry about the number out front when it goes to molar mass. This question I can also ask you, you know, what is the molar weight of CO2 or what is the molar weight of H2O? So if you see a same question, I'll tell you now, because I'm going to be very lazy about, you know, throwing out specific questions on the exam, but it's not going to be identical to what you saw before. So just make sure you read the problem really well, because I can ask this question a variety of different ways. So I'll ask something else, or I might even change the equation. Instead of butane, I'll do propane, but you're going to see similar things. A typical lighter holds 3 grams of butane. How many molecules of butane are in the lighter? So very similar to what we saw in the short answer problem is you need the molar triangle and you need to convert it. So I'll give you a minute to try to go through this problem. What is the representative particle for butane? It is molecule. It is a covalent molecular compound. And so for me to use the mole triangle, I need to remember that 6.02 times 10 to the 23 will represent molecules for this problem. So 3 grams of C4H10 times, and I want molecules, 6.02 times 10 to the 23rd molecules divided by molecular weight you just calculated. And what'd you get? D. Did everyone get D? Then it's D. I just don't feel like typing in my calculator. I support y'all. But yeah, so just make sure you can set up that triangle. All right. If 7.932 moles of butane burn, how many moles of elemental oxygen are required? This is a mole to mole. So all I need to do here is kind of use the equivalence or the stoichiometry. This is a stoichiometry problem. So it says butane. That's mole of butane, and I'm gonna bring out that 2 up front. And then it says oxygen, so that's here. I'm gonna bring out the 13, and that's moles of oxygen, something like that. I could ask this problem with regards to any of them, but I need to focus on the ones it is asking it for. So I'm starting with butane, and I'm turning it into oxygen. So if I have 7.932 moles of C4H10, on top I want oxygen, so that's 13. And you set it up like that. The numbers that are inside of that one it just comes from the mole triangle, because inside the triangle it's 1 mole, and so I'm just saying 1 mole. But if you wanted to just take out that 1 and just replace it with a 13 or a 2, that also works.
So the calculator, we just.
Yes, so this number times, in parentheses, 13 divided by 2, or this times 13, enter, divide by 2.
Okay.
That's if you're going moles to moles. 7.932 times 13. 51.56. Did y'all get that? Awesome. So yeah, I can just change up this number. I can say, you know, go from, let's say we go from oxygen to H2O. All you have to do is bring down that number. So if I want to do H2O, I'll just put the 2 out front. I'll put the 13 on the bottom. So no matter what I do, no matter what I give, you can play around and just double check and make sure you're putting things in the right location. So we're still, it said the first 8 questions, so we're still using the same balanced reaction. So STP stands for standard temperature and pressure. So assuming STP, how many liters of carbon dioxide can be made from 6.8 grams of butane burnt? So like I said, this question is using stoichiometry, and we have to be able to use the mole triangle to go back and forth between two substances. So it's starting with butane again. So from the mole triangle, I need to have the molar mass because it said grams. I'm starting with grams, but I just want to make sure I bring that stoichiometry out front. So somewhere in this, equation, I'll have to have a 2 times the molecular weight of butane. And it's asking for how many liters of carbon dioxide. So inside parentheses, I have what's from the mole triangle. Outside parentheses, I have the coefficient. That's how I kind of set these up. So if I'm starting with 6.7 grams of butane, and I'm trying to get liters, so I'll do 22.4 liters of CO2. And then the bottom, I'll do 2, and that's the molecular weight, which was 58.14 grams of C4H10. So if you're comfortable using the mole triangle when you have one substance, this is the exact same thing as before. The only thing that we added to it is we added the coefficients from the balanced reaction. That's the only thing that changed going from, previous problems to this problem. So just don't forget the stoichiometry. And then double check and make sure you're typing this into your calculator right, because if you don't have the top in parentheses and the bottom in parentheses, that might throw off your math. So 6.7 times, and I'll do 8 times 22.4 in parentheses divided by 2 times 58.1. I got 10.33. But it's not, I didn't get it. So because it's 2 sig figs, she wrote the answers in 2 sig figs. So 10.33 will round down to 10. Did y'all also get that, or was there a calculator discrepancy?
I did.
Okay. Easy fixes, but double check and make sure that we get that now.
Why did we get stoichiometry on number 2?
Number 2? We didn't on the previous problem. So, on 2? Because if you're going from butane to butane, if you want to include the stoichiometry, you could. It's just 2 divided by, it ends up being the same number. So we don't do stoichiometry when we're focused on one thing. So you're welcome to, if you want to leave the 2 out front, you're welcome to put the 2 out front, but you'd get the same answer regardless.
Where else?
Here is when you need to start incorporating the 2 out front, is when you're going from one thing to another. So for us to be able to convert using ratios, that's when we use the number out front. But if we're focusing on just one thing, don't worry about it. So yeah, this is what we did in 2.3. This is just an additional step when we're going from one thing to another. Are there any more questions on that? I understand it's a little tricky. Sorry, I'm getting a lot of emails that are very important. Sometimes, I don't know if y'all deal with this, but whenever something is wrong, and when you bring it up to people, instead of just listening, they double down. And I'm like, you're doubling down, even though you're completely, I don't get this. It doesn't get better. It doesn't get better the older you get. I'm like, people just keep doubling down. It is a pride thing. And sometimes I catch myself wanting to do it. And then I'm like, what if I'm wrong? I'm probably wrong. Yeah. don't be like that. Okay, number 5. How many moles of carbon are found in 2C4H10 when we interpret the coefficient in moles? Okay. I like this question. So if I had 1 mole of C4H10, how many moles of carbon? So if I had 1 mole of C4H10, how many carbons? Previously, we were doing equivalents, and I know that my question was complicated, so no worries. Previously, when I've asked y'all, I would say, okay, if I have 1 molecule of C4H10, how many atoms of C? And y'all all got that right. It's the same concept if I was to do, okay, if I have 1 mole of something. It's all a ratio, right? So if I have 5 moles, 10 moles, 20 moles, it's still the same concept. So if I have 1 mole of C4H10, I will have 4 moles of carbon and 10 moles of hydrogen, all ratios. If I have 2 moles of C4H10, how many moles of carbon? Yes. So this one, I don't want you to get tripped up by there because previously y'all are 100% right every time I ask you about atoms. You can continue using that same ratio. If I take out the molecule and replace with mole, it's the same number. So it's just 2 times 4 here, and that would be 8. I think so. I think so. I like it. I like the question because it's made to think, oh my God, there's no way this is the same answer. There's no way, right? It's really testing how comfortable you are with your knowledge.
Yeah, that's between my. I was like, oh, well, it can't be. I wonder how can I change it? That's gonna be just fine.
Yeah.
But
I think that's something I struggle with myself is I second guess myself. And it took until I got the ability to like answer multiple choice questions by using deduction reasoning that I'm like, okay, I'm better at this. But if I didn't use that, I just would second guess. I'm like, there's no way it's 5 A's in a row. There's no way it's the same question in a row. So I think your first instinct is usually right. And so my advice would be never to like change answers 5 minutes before you turn and examine unless you're 1000% sure of it. In this case, yes, that one answer would be D for 5. And then how many atoms of carbon are found in 2C4H10 when we interpret? Same exact question. So it's a ratio. So if I'm comparing moles to moles, atoms to molecules, it's the same number. So trust your gut. Yeah, and I do like the fact that those are back-to-back questions. Yeah, and let me know. All right, number 7, how many grams of butane have to burn in order to make 100 grams of water? So yes, this one's not quite, I'm given this is more of like an estimation of like, okay, if I want to do this, what do I need to do? But it's the same type of setup. We're going from grams to grams. So I'm gonna do what I did before where like using the mole triangle, I need the molecular weight of butane, but I want to make sure I bring that stoichiometry down with it. And it's asking for water, and it's grams of water. So I'm also needing a molar mass of water, but I still need to bring down the coefficients. It's very important for us to do that for this to be done properly, to go from one thing to another. If I'm starting with 100 grams of H2O, and I want to convert to butane, I need to put the molecular weight on top. And for water, it's 18.02. Sorry, my handwriting's so messy. So very similar to before, like all I'm doing is just changing up units and changing up like what I'm focusing on, but the concepts don't change. What goes in parentheses is from the unit triangle, the mole triangle. Outside the parentheses are the coefficients. Okay. Let's answer this one and then we'll take a mental break. That's 100 times, and then in the top, I'll do 2 times 58.14. And then the bottom, I'll have 10 times 18.02. And I got 64.53. So that would be B. When we leave here today, when y'all start like really studying for this exam, I highly recommend y'all try and answer at least all of exam 3 without your notes. because that'll point out what needs to be studied to get you ready. It's okay to have your notes while you're studying, but the goal is to be able to like try to answer these problems without any additional help. Any questions on that? All right, so it is now 12:50. Let's come back at 12:56. This next question could be complicated, but I just recall from the very beginning of this problem, it said for the next 8 questions. So this question 8, is kind of using the same reaction as questions 1 through 7. So when I'm looking at this one, I can get quite confused by it because I'm like, but there is no subscript G, but it's asking what's after. So yeah, so remember that it's still part of this problem, but when what does this G mean? Yeah. So if it's in parentheses like that and it's after something, that's a gas. If it was AQ, it'd be aqueous, L for liquid, S for solid. So this one has to be gas. So yeah, I feel like when I'm looking at all these answer options, it can be quite confusing. But if I know, okay, we'll look at the problem itself, it helps make things a lot more simple. Okay. Which of the following contains only metals? This one I think is a very similar problem to what y'all saw in exam 1. What I do is I typically will go through and eliminate what makes no sense, like oxygen is definitely not a metal. Bromine is definitely not a metal. Boron is definitely not a metal. It has to be D. So it's okay if you're not as quick as me. Like I just have a lot more experience, but it doesn't mean like anything. So that's how I kind of answer it. Instead of me having to double check everything, I just kind of look and say like which one is definitely does not belong, and then I'm able to figure it out. So boron, I know where it's at, number 5. I know things like that. But this just takes a little bit of practice. How many oh, I love this question. How many oxygen atoms are represented by 4 barium nitrates? So in 1 barium nitrate, we have 6, so 3 times 2, but there are 4 of them. Yeah. So in this case, you have to use the coefficient out front because I have 4 individual molecules or formula units of barium nitrate, and they all matter. Question. Oh, go ahead.
Sorry. Cause I know one of the previous one said not to worry about the coefficient, but that's just for the.
That's only molar mass. Yeah.
Okay.
What is the name of this compound? Yeah, ammonia, not ammonium. You are going to be expected to be able to like name this if I was to throw this at you. So NH3 is ammonia. So if I have NH3 and it's dissolved in water, which one of these represents NH3? I think you're right. Your instinct's right on. So I'll point out NH3 is a molecular covalent compound. It does not break up into ions when it hits water. That's what this question is asking. If this was asking about NaCl, let's say I have NaCl, sorry, these are so ugly. Let's say this is NaCl before it hits water. And this is a beaker of water. When NaCl hits water, it breaks up into Na plus and Cl minus. Because ionic compounds are electrolytes and they break up into the ions when it hits a liquid like water. If it's a molecular compound like NH3, it does not break up into ions. It's not an ion. It's a molecular compound and it stays the same. It just breaks up into its individual molecules, but that's what this question is asking. It's just challenging, okay, do you know what type of compound it is? So metal plus non-metal will break up into ions. If it's all non-metals, it will stay together, like sucrose. I showed y'all that FET simulation. Do y'all remember that FET simulation? So sucrose, when it hits water, it just, comes into individual sucrose compounds, whereas NaCl breaks up. So if I was to like say, something like this, NH4 plus. Is it an ion? So if there's a charge, it's an ion. But in the same concept of NH4 plus does not break up into any more ions. It's just going to be NH4 plus. It's a polyatomic ion, so it'll be A anyway. The only time it would break up and look something like this is if this was like NaCl. Okay. Just challenging your ability to understand how things break up when it hits water. That simulation is very helpful. All right, here is another question. Which image best represents AlCl3 when it hits water? First, is it ionic or molecular covalent? It's ionic because it's a metal plus a non-metal. So what happens with aluminum breaks up into water. So AlCl3, let's say it's a solid. When it hits water, it breaks it up into Al3 plus and 3Cl minus. That's what's going to happen when it hits water. It's an electrolyte. It has the positive and the negatives. Out of these answer options, which one shows that? A. So A has your aluminum 3 plus and your 3 chloride. B would be, I guess, AlCl3 before it hits water, so it can't be B. And C doesn't show the full breaking up into ions. So this is an electrolyte, it has to break up. So remember, if it is a polyatomic or if it is all nonmetals, it stays together. It stays together when it hits water. If it's a metal plus nonmetals, it breaks up. So I love this type of question because it just challenges, okay, do you understand, is it molecular or is it ionic? So remember, I like this question. Maybe I'll ask you this question again, but all I'm going to do is just change up the letters. So I'm just going to challenge you that way.
So we see, I know one of the homework, it had, strong, weak, and, electrolyte. Are we supposed to know the difference between strong and weak?
I don't think I'm going to ask you that. Maybe I can ask you, like, I can say this is a strong, weak, or a non-electrolyte, or I could do strong versus non. I don't know if I would ask you about the weak versus strong, because we haven't gone into that yet.
So much strongly like the B.
No, strong breaks up.
Okay.
Strong 100% breaks up. C would be a weak one, where it partially dissociates. But we haven't really gone into all those details yet, and so I would never make you go between strong and weak. I would probably make you go between strong and non. So sucrose versus NaCl, like the PhET simulation. That's what these two questions were. You had non-electrolyte and you had electrolyte. And that's going to be more like them to ask you.
So would this be a strong one? If we break apart?
Yeah, I'm not 100% sure what it is, but we're going to assume it's strong. Sorry. Their electrolytes have a beautiful range. Like it has a giant range where some just don't break up or they have like a little breakage, but that's definitely not what we're going to cover in 1320. It's more of a Gen Chem 1 type stuff. So I'm not going to challenge you on that. Just know that there are weak, like calcium carbonate. Calcium carbonate is I guess, we have it in our pipes a lot, you know, that like white dust that's a residue in our pipes because you have calcium from our water supply in our pipes, and then you have carbonate, which is a nice basic property too. It does not dissolve well in water, but it's still a metal plus a non-metal. So it is electrolyte. So some of it breaks up into water, but not 100% of it.
Calcium buildup.
That's what that is, that calcium buildup. So, but I'm not going to ask you about that. So I'll stick to the easier ones. All right. Any questions about that? So like I said, instead of aluminum chloride, I can ask you aluminum bromide. I can ask you iron bromide, iron iodide, things like that. But metal plus non-metal breaks up into ions and will break up when it hits water. Non-metals will not. Polyatomics will not break up further. So if I have NO3 minus, it's not going to break up into nitrogens and oxygens. It's going to stay as NO3. So this one says, write an unbalanced skeletal equation from this description of a chemical reaction. So we did this a lot last class, where I spelled out a reaction and we were supposed to not only write out the reaction, but balance it. This question is really nice. They don't actually ask you to balance, but maybe I'm not going to be so nice and I'll say balance it. First, if I give you an element by itself and it's not a Brinkelhoff, you can assume it's by itself. So iron plus silver chloride, that means it's going to be iron plus something. What is the element for silver? So silver is Ag, gold is Au. So I already can eliminate D because it says gold. All right, so it's iron and silver chloride. What is the silver? Okay, what is silver's charge? Always +1. What is chloride's charge? So what does silver chloride look like? AgCl. We don't crisscross. +1, -1, AgCl. I can already eliminate answer option C. And then it forms to react to create iron 3 chloride. So sorry, we have Fe plus AgCl. So Ag plus Cl minus does not need a crisscross. All right, but iron, it says iron 3 plus and chloride minus. What does iron chloride look like? This one does require crisscross. So iron chloride will look like this, FeCl. JLCl was able to do that. I just eliminated as I went, but also you can write out the equation and what makes sense. But just make sure that you double check the charges to have the balance reaction. Because if you just left this as FeCl, you can see how if I asked you to balance it, it'd be a giant mess. Let's balance it. What do I do first? So I'm looking at the chlorides. The only thing that's wrong here is the chlorides, chlorines. So what do I have to do over here to get it to be a 3? Okay. So now I have 3, but my Ag is now 3. Perfect. All right, so I can make this into a 3-step question. I can say, okay, balance it now. What is the sum of the coefficients? So 1 plus 3, 1 plus 3. So 8. So you still need to be able to balance it. If I was to give you the reaction like this, can you create it? Can you balance it? And I can ask you questions like, okay, add up the coefficients. But yeah. Okay, I love this question because I feel like I didn't hit on it a lot during lecture, but it's something you might know already. Which of the following elements is the most similar to oxygen? Look at the columns. So the way the periodic table of elements works, I have no clue how it worked out like this. I really don't, because I'm like, there's no way that it miraculously did this. The columns are similar. They have similar properties. So column 1, they all have that +1 charge, right? And so even though they have very different masses and the masses are getting bigger, they still have similar properties. So cesium will have similar properties of lithium, even though they're very different on the period. It's just column 1. Column 2, same concept. Column 3, column 4. So oxygen, sulfur, and selenium will have similar properties together. If you're comparing oxygen to nitrogen or fluorine, it'll be closer to sulfur than it will be to nitrogen or fluorine. So with this type of question, I'm just asking you to pay attention to the column, and whatever one is on the same column with it is the correct answer. So this one has to be A. It might be closer in weight to nitrogen and fluorine, but it's going to be closer in properties to sulfur. I'll let y'all do number 15. So you'll have y'all's notes in front of you. Go ahead and balance it and add up all of the coefficients. Yeah, I agree. I think I'm gonna have to double everything because it's an odd number, right?
That should be.
Oh, there's eight. Oh, thank you, thank you. I was like, there's no way. That'd be very complicated. So eight. So eight, four, and then I put a four right here, right? Else. Okay, so that's 1 plus 4 is 5, plus 1 is 6, plus 4 is 10. Y'all got that? Perfect. I'll skip 16 and let's do number 17. Y'all go ahead. So for this one, like when I'm reading it, it says solid iron oxide can be reduced to iron. Just note that that just means that your product is going to be solid iron over here. If it says iron metal, you can assume that it's a solid. Hydrogen, this is going to be gas. And then water is a byproduct. I don't know if that water is a liquid, gas, but we'll see what happens. Is it a liquid? Is it gas? I don't know. But first, before I can even balance this reaction, I need to make sure my iron oxide is correct. So what is iron oxide? Yes. So we have FeO, so Fe2O3 plus H2 gas becomes Fe solid plus H2O. If I look at these answer options, I'm going to eliminate A because it does say solid iron oxide right here, and A is showing that it's a liquid. You see aqueous? Aqueous means liquid. So I'm going to eliminate B2 because it's saying the same thing. Whereas D has solid, and it has a gas. But let's double check because maybe, maybe the balancing is off. So let's balance this real quick. So I have Fe, 2 and 1, O, 3 and 1, H. What should I do? Okay. 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 Awesome. So yes, let's come and check. Okay. These are both balanced the same, but which one do you think is the best symbolic representation? Why? It does. So based on the way that she wrote this question, saying solids and gases, C is a perfectly acceptable way of writing it, but if it says the best, it's going to be D. Typically, I don't like questions that are like, what's the best answer? I feel like biology does a lot of those types of questions, which is why I hate it. But with this one, I don't do a lot, I promise. That one's hopefully more obvious. How are y'all feeling about these types of questions? Y'all feeling a little bit more confident? Okay. 18. A reaction vessel contains these reactants. Question, reactants are on what side of the arrow? So reactants are left, products are right. So these are the reactants. It says the darker are carbon and the lighter oxygen. So lighter, these are O. So I have, this looks like 2O2. So based on this, I have 1, 2, 3, 4. And 2O2, based on this picture alone. The reactants undergo a reaction as shown by this equation, okay? Which of the following choices shows the contents of the vessel when the reaction is complete? So it looks like what I have here is like double this reaction. Do y'all see that? So if you take the reactants here and you multiply it by 2, you get this, right? So I would hope that whatever answer option is here is just going to be 4 CO2. Because if I double these two, I have to also double this one. So I'm looking for 4 CO2. What do you think represents 4 CO2? B? Yeah, B looks right. Yeah, see how I was able to do that? Yeah, I looked at the picture and I just kind of counted, okay, these are COs, these are O2s, and I counted them. And I'll tell you now, with the balance reaction, they're not gonna always have it like 4 plus 2 plus 4, because you can simplify them. It's always the most simplest version of it, but it's okay, we just doubled it. So if I have double the amount of reactants, I will also have double the amount of products. So it won't be 2 CO2, it'll be 4 CO2. So B has to be the right answer. I love that question because it's like out of and left field, but it's a good challenge. I think that's definitely like a ACS level question. Which chemical equation best represents the reaction shown? The lighter spheres are hydrogen and the darker spheres are nitrogen. Now I'll go do this one. All right, so it looks like it's 2N2, 1, 2, 3, 4, and 6 H2. Let me just put a underneath. So I have 2N2, 6 H2, and then one, so that's 1, 2, 3, 4. It's 4 NH3. So what can I divide all these numbers by? So it would be N2 plus 3H2, 2NH3. So what answer does it have to be? Yep. Yeah, because if you're looking at it now, at least she was nice enough to not have an answer where it matches the 264. So if it doesn't match, I mean, I kind of like this because I don't see an answer that matches it. I'm like, okay, something else is wrong. Let's try to figure out how I'm gonna get better. Don't just guess and say it's A because that's closest. It's not, because there's 6, not 5. So that leaves it having to be D. Let's go ahead and do 20. So I got, let's see. The first thing I do is I gotta get this O's to be even because I have an O2 over here. So I'm gonna put a 2 out front. And that means that I have to put a 4 here. And then a 3 here. So what is the answer? Yeah, 7 plus 8. Not so bad. All right. Almost done. How many moles are in 15.5 grams of diphosphorus pentoxide? What is diphosphorus pentoxide? All right, if it says grams of diphosphorus pentoxide, if I look at my, not focusing. If I look at my periodic table of elements, or if I look at my mole triangle, I need the molecular weight. So what is the molecular weight of P2O5? How'd you get that so fast? I'm very impressed. I'm like, I don't even know that I haven't memorized what phosphorus is. All right, first you need molecular weight, and then mole triangle. 1 mole equals, do I need represented particles for this problem? So I'm starting in grams and it's asking for moles. Is moles a represented particle? Remember, the represented particle is the smallest version of something, so molecules. It's going to be one of these. So if it doesn't have those keywords, it's not looking for represented particles. Moles is a big number. So moles is not going to be, so I don't want to actually use the wrong number here, because if you do, it'll throw off your math. So I need to go from grams to moles. So you divide it by the molecular weight. So 15 divided by a big number, I assume it's a small number. It's not going to be B or C. What did y'all get? A? Okay. Yeah, so remember, use the mole triangle, but use those keywords. If you don't see liters, don't use 22.4. If you don't see grams, do not use the molecular weight. And if you don't see one of these keywords, don't use 6.02 times 10 to the 23rd. So if you have to like write out those equivalents and say, okay, well, I have 1 mole. This is the same thing as me taking the mole triangle, but doing it kind of like what we did on the slides. Like that's the mole triangle right here. They're all equal to each other. And if I look at the question, I have grams and moles. So I'll do here. And I'll say, okay, the only 2 things that I need for this problem is grams and moles. So I don't need to go, I'm not even going to try to use any of these numbers. Okay. Yeah, I'll do number 22. All right, so we have, looks like we have 1, 1, 4, and 3. So I need to have, looks like these are all even numbers. I'm gonna have to put a 2 up front here because I want my oxygens to have be an even number. So I'll do that to get 6, 2. So I'll put a 2 here. Now I have 2, 2, and 6. Okay. Did y'all also get that? 2, 2, 1. Number 23. Do y'all remember the names of those elements? Do y'all remember what column the chalcogens are? And if you don't have it memorized, eliminate what it's not. It's not column 1 or 2. Those are alkali metals, alkaline earth metals. It's not the middle. It's not a transition metal. That leaves the other side. It's either going to be, it's not, one column is noble gases, one column is halogens, one column is chalcogens. Which one is the chalcogens? Oxygen and down. Yeah, so third to last. So don't panic if you do see a question like that. Eliminate what is not, and that might help you isolate it. So lithium definitely can't be it, magnesium, and then it just honestly halogen versus a chalcogen. Halogens are going to be the fluoride, chloride, bromide. So A. All right, I like this question too. Which will have the largest molar mass? So if it's just an element, I can go to the periodic table of elements and find the number. If it is a compound, I will have to do the math myself. So carbon's 12, oxygen's 16, so 28-ish. And that's 14 times 2 at 28-ish. All right, so argon, 39. What about 10? Yeah, 10's the biggest. It's like 1 something. Yeah. This one, just look at the periodic table of elements and figure out the biggest number. You might need to do a little math, but that's okay. Huh? I'll find it. Yeah, it's
The row of carbon,
Oh,
Yeah.
and
oh, got it, got it.
So when potassium sulfate dissolves in water, what is the best description of the particles present? Ooh, I think we're ignoring water molecules. Okay. What do y'all think? Is it ionic or is it molecular? Trust yourselves. You know it. You know it. Potassium is a metal, so it is ionic. Like, y'all, I can see y'all second guessing yourselves. Y'all know this. All right, what is the charge of potassium? Okay, and what about sulfate? What is the charge of sulfate? Two minus. All right, so it is ionic. So if I was to dissolve it in water, it breaks up into ions. But sulfate does not break up any further than this. It stays together. It's SO4 2 minus and K plus. But there's a 2 next to the potassium, so that means that there are twice as many potassium ions in solution as there are sulfate. Does that make sense? Okay. So it says 1 potassium sulfate molecule. Is that correct? It can't be. It can't be because it's ionic. It's not a molecule. It could be a formula unit because ionic compounds can be formula units and break down further, but it cannot be a molecule. So it can't be A. 1 potassium ion and 1 sulfate ion. Y'all think that could be it? I have to have twice as much potassium in solution as sulfate because of that 2 next to the potassium. So it can't be B. 2 potassium ions, 1 sulfide ion, and 1 oxide ion. Remember, polyatomic ions do not break down further. Keep them together. That sulfate will stay a sulfate. It'll not turn into sulfurs and oxygens. It will stay together. It cannot be C. And then 2 potassium ions and 1 sulfate ion. It has to be D. So stays together. Okay? Okay, so that's all I have for the exams, but that gives us about 8 minutes to like, I can answer questions if you want to get your homework out, or if you want me to, cover another question, please ask, because we're gonna come in on Wednesday and just do the exam, and then you can leave when you're done. Okay?
Well, that other test, within 5 questions, right?
For the first test, let me grab it. We did most of the questions last class,
Oh,
so, but I have them highlighted. So here's what we did last class from the first test. Most of these ones come from exam 1, but they can still be asked on exam 2. Like I might throw in a couple exam 1 problems.
sorry.
Yes, but like I would say these ones 12, 13, no, 12, 14. Yeah, these ones are the ones that are specifically unit 2. So 12, 14, 15, 16. Yes, exam 2 can have some exam 1 questions. Not a lot, but I might throw some in there to keep you challenged. But like also some questions will require unit 1 knowledge. Like for instance, I don't know what question, but like any of these questions where it talks about naming, you have to know unit 1 naming to answer these properly. So I'm forcing you to remember unit 1. Yeah, these are also unit or exam 2 questions from exam 2.
Like, would it be wise to do both and then also do?
I think so. I think it'd be wise when you're practicing to do exams 2 and 3. I think, even though we went all over the answers today, print out a new copy, or if you want plenty of copies, grab an extra couple copies, so I don't have to throw them away. I'm gonna recycle them, but grab some extra copies and then practice units or exams 2 and 3 from them practice over and over until you can do them without help. The goal is to not need gender. And also get more confident with yourselves and not second guess yourself. Okay, because we have 2 days, we have 48 hours to get more and more confident. And I feel like y'all are already y'all got it. Okay, and also if you haven't finished those quizzes and homework, do them today so we don't have to think about them over the next 2 days. Yeah.
I do.
You feel better?
I do, but I needed this for a long time. I can't have
Stoichiometry?
big down.
Yeah. It's a hard concept and students it's a very hard concept even in Gen Chem, even in quant. It's just something that you either get it or you don't, but we have to get you to get it.
Yeah, it's like hard, like the whole system of like dragging, once it's to set up the equation, I don't think it's so laggy and it's
Which one?
I think it's on the phone, but like dragging the things there, like sometimes the words collide into them. I'm sorry. But, yeah, I didn't understand. But now I understand it more. Just setting up the equations, that always throws me off.
Yes.
I memorized the triangle,
But how to use it?
Yeah,
Yeah, that's the thing is like, yes, it's important to have it memorized, but we need to just practice using it. Because I'm not reinventing the wheel. I'm not coming up with new questions. I might be asking the same questions, but going between 2 other things. And I'm changing the numbers, I'm changing the compounds, but the concepts are not changing. And just practicing it a few times until you get more comfortable is the only thing you really can do. If you want extra copies of the polyatomics, I have them if you want. You want one? For the.
yeah, I missed.
They're available if you want to print them out.
This is my sending print, so I was figuring through it.
Yeah, have extra copies.
Thank you.
Like I said, take extra copies of the blank exam so you have them practice. Take as many as you want. I'm gonna recycle them. But if you'll have any further questions, or if you want to look at the homework, if you had a question on the homework, I'm here. I'm gonna stop the recording